Alright guys, let's dive back into animation, specifically control rig. After the animation layer video and the twins tool video I posted a few weeks ago, many of you asked about the control rig I created with the secondary dynamic motion for those animations. I've put together a complete breakdown in this video for you all guys. So now, let's check this out. And as you may have recognized, it's Squidward from SpongeBob. I thought it would be a great fit for this video. I've just set up a quick rig in Blender, and as I've mentioned in other videos, I'm working on skipping this part and sticking to Unreal, even for the rigging and skinning steps, thanks to the skeletal mesh editor. I still have a video to make for you guys since Unreal Engine 5.3, as it has evolved significantly. Alright, once I added some bones and adjusted the weights, I jumped directly to Unreal to create a control rig, starting from the skeletal mesh as usual. The goal here is to add secondary animation motion from a control without having to keyframe everything. It's like playing with physics. You can create a variety of effects with this, which is really fun. For this example, I wanted to animate Squidward's nose, arms and legs using different approaches. I begin by creating basic control for the roots and the hips. We don't need to create every control here, I just want to get straight to the point for you guys. Bring your controls in Get Transform, then your bones in Send Transform. Let's connect everything and place right from the beginning a sequence node to organize everything later on. Now let's select the nose bone, bone 02, and create the appropriate control for it. We'll adjust the shape and placement, then place it under the hip control to maintain a bit of hierarchy. With just this control, we can achieve nice, smooth movements. You'll see it in a bit. Now let's talk about the logic behind it. First, we need to get the transform of your control. Remember, you can do it by selecting and dragging the control directly into the graph. Next, prepare the bone that will be driven by this control, which is in this case the nose 02 bone. The interesting part comes when connecting the two nodes, which can be done using the simulation category. Right-click in the graph to access the node library. Simulation nodes will execute at runtime, without needing to launch the play mode in the sequencer. Plus, if you bake the animation created with these nodes, it will be saved just like any other animation driven by traditional controls. This is similar to the dragon example found in the control rig pack. There are quite a few options here, but I pick one common node for now, the Spring Interpolate Quaternion node. This node will add secondary dynamic motion to the bone chain following the initial control setup, in this case the nose 02. As you can see, it focuses only on rotation for now. We need to enfold the control's output to properly target its rotation and connect everything just like we did in the set bone node's value input. At this point, we can proceed but be mindful of this type of node. By default, it operates in the control rig space, meaning that if you rotate the reactor itself in the level, the dynamic effect won't show up. This is why we need to set up a two-word node and a forward node before and after the Spring Interpolate node. This ensures that if you manipulate the actor or the skeletal mesh itself, or use a blueprint actor containing the skeletal mesh component for example, it will work. After adjusting the values, compile everything, now you can see the effects by rotating the nose control. However, if you play with translation, you'll notice an issue. This is because we didn't specify the input for translation. To fix this, simply connect the translation output from the control. Now when you try it again, there's no issue, but the nose won't jiggle. As I mentioned earlier, it will only work for rotation. And the cool part is that you can add translation logic on top of this. Trust me, it's not that complicated. For translation effects, the node you need is the Verlet Node. This node, based on mathematical calculation for trajectories and more, will add a delay or jiggle effect based on the translation for your control. Just like the Spring node, we need to specify the space with the two-word and from-word nodes. Then we can connect the translation inputs with it directly. With the input properly specified, the effect now works perfectly for both rotation and translation. This is the same technique I used for the raptor's arms in the animation layer video. For the arms, let's use something different. We'll use the attach chain to spline function to recreate the effect I did with the raptor's tail or the stylus dino in the twin tool video. This function requires points to be specified, so I'll first create the controls. To make it easy, we'll create the entire chain and pick what we need in the end. I create control from tentacle 1 to 8, then properly parent them in the hierarchy. The key here is to avoid using all the control as points, as this could cause the effects to be located just at the end of the chain. it's better to pick some controls along the chain. But let's take everything for the moment just to demonstrate that. I select the controls I want and then drag and drop them into the graph to select the item array function. From the controls array, I get a transform array node, followed by a transform array to SRT node to isolate the translation attributes since the point input is a vector type. Now I can create an item array from the concerned bounds as well, respecting the order. I just need to specify the primary axis, and since it's coming from Blender, the y-axis is the main orientation, but I have to set it to negative for it to work properly here. And that was just step 1. The other step is to create the delay and jiggle effects for the chain. Remember the node from earlier? Yes, it's the Verlet Node. The trick here is to create an end control from the final bone in the chain and parent it like I'm doing here. This will be the Verlet control. In addition to the chain controls, the Verlet control will be the basis of the same logic we used earlier. From a get transform control, we use a two-word node, then connect it to the Verlet node, which we can adjust to fine-tune the intensity of the effect. Finally, we use a from-word node and a set transform node. Be careful here, as we won't specify a bone, but instead the end control of the chain just before the Verlet control. This ensures the correct behavior and makes it compatible with Unreal when using both the attach-to-chain node and the simulation node. I prefer to connect the logic prior to the attach-to-chain node using a sequence node. Now when you test it, you can see that the result is located at the end of the chain. It could be what you initially wanted, but the best is to pick, for example, the beginning of the chain, then some in the middle and the last ones. Here I pick control 1, 2, 4, 5, and 8. Don't forget to arrange bones array 2 with the correct order. Now if you play with it, you'll start to see nice results, and it's so fun to play with. You can replicate the same thing for the other side of the arm here. You always need the both setup here, Verlet Node at the end and the attached chain to spline. If we test our dear Carlo in a sequencer, yes, that's how we call him in France. You can animate and create nice effects out of all this setup, and it is pretty awesome, right? Another quick part I wanted to demonstrate is for the legs. IK nodes are great for dynamic effects, and CCDIK is a simple yet effective one to use. To properly set this up, I created an end control for each leg. Let's start with the front left leg first. From there, I use the Verlet node again, following the same logic as before. For the CCDIK node, I'll specify the bones involved via an item array. Don't forget to specify the scale and rotation from the initial control to avoid deformation. I repeat this process for each leg using separate pins from the sequence node to make everything clear and organized. Now when you play with it, you'll see a fun, dynamic effect that behaves similarly to a tentacle. Now you know how to create effects like this inside Control Rig with simple yet effective nodes. Takes some time to perfectly adjust everything, but depending on your character, you can manage quite quickly nice effects. You can create any animation in your sequencer with it, and baking an animation asset, for example, would easily work too. If you want to go even further, and it really helps me master these nodes, feel free to check out Tony Baron's video, which features tons of other examples showcasing great uses of simulation nodes. Thanks for watching this video, guys. Don't hesitate to subscribe if you liked the video, and see you next week for a new one. Ciao!